Okay. This is just to kind of help you think about and review those identities. I'm hoping that over this next little bit that we're going to be looking at here, you're going to see many of you guys kind of already have these memorized, which is great. The sooner you get these memorized, the easier this is going to seem for you. So for the next little while, during classwork and homework, you're going to want to keep that reference sheet until you know you have these down pat. Keep that reference sheet as just part of what you're doing, please, okay? All right, so we are going to start looking at what's referred to as simplifying identities. Kind of some general rule of thumb for most of these. We don't want fractions, so if we see a fraction, we know we're going to have to do something. And in general, what tends to make things the easiest, what tends to work the best in terms of doing the simplifying is that if we see something that is not written as a sine or a cosine, we're going to rewrite so that it is, and we're going to simplify using sines and cosines. Now, our final answer might not involve sines and cosines, but we're going to, when we can, we're going to rewrite using sines and cosines. Might not make much sense yet, but you'll see here in just a second. All right, keep that reference sheet handy. I'm going to kind of color code a little bit here to help you with thinking about the different parts. So I want to rewrite that cotangent, and I want to rewrite that not as a reciprocal, but using sines and cosines. So I want to think quotient, not reciprocal. So Brock, how can I rewrite that cotangent of x using quotient identities?
You just write it.
Where are your identities? Cotangent of x, how are we going to rewrite that? If you haven't written out your reference sheet yet, you better. Sines and cosines, quotient identities, not reciprocals.
Those?
Yeah.
Oh, sine x over cosine?
Read that again. Cotangent of x is what?
Oh, cosine x over sine.
There you go. Okay, so cosine of x over sine x. That's how we want to rewrite that cotangent. And I want to rewrite that cosecant. That is reciprocal. So Larry, how do we rewrite that cosecant as a reciprocal?
1 over cosine.
Oops, careful. 1 over, God bless you, by the way.
Oh, sine.
1 over sine of x. Beautiful. Okay. I'm trying to color code. That may or may not help you. Here's the other thing that I know tends to happen. I get excited just thinking about these problems and working on these, and I start going pretty fast. So you may need to slow me down or tell me to rewind. But you have to be thinking through what's going on here. And if you don't understand what somebody's saying and we're progressing, you got to stop me so we can back up. Okay? All right, we're not done here. I just wanted to mention that before I got carried away and started zipping through this quickly. We've got complex fraction here, so we need to do keep it, change it, flip it. So that 1 over sine x is going to flip and become sine x over 1. Now what do we notice that happens there? Sines divide out, and what are we left with? Cosine x. So that is the simplified form for that identity. You've just simplified your first identity there. Perfect. Not too bad, right? We're just looking at what we know and kind of rewriting. Then we've got to kind of use some math to simplify, right? Okay. I'm seeing sines and cosines, so I'm going to keep those as they are. But I definitely want to rewrite this secant, and I definitely want to rewrite this cosecant. So let's think about how we're going to rewrite that. Now, part of me says I'm looking at this and I'm seeing fractions that we need to try to add. So you want to think common denominator, and that could work also. But I think this one in particular, you'll see is kind of easiest to switch these into sines and cosines first. So I want to write that secant. I want to keep the numerator the same because it's already a cosine, and we like that. but I want to rewrite that secant of x. How can I rewrite that secant of x using sines or cosines? Nick, what do you think? 1 over cosine x. There you go. Awesome. Okay, and then we have plus, I want to keep that sine x the same, but I want to rewrite that cosecant of x. Tate, how can we rewrite that? 1 over the sine of x. Okay. And now, guys, if we do keep it, change it, flip it here, we think of this as sine of x over 1, and we multiply. At this end here, we get sine squared x. Here, we get cosine x over 1, so we get cosine squared x. So we've got cosine squared x plus sine squared x, and what do we know that that's equal to? 1. That's Nick's identity, isn't it? Who else has identities in here? Nick? Mikey, what's your identity? Squared x, okay. So 1 plus tangent squared x is secant squared x. Who else has an identity in here? Okay, what is it?
1 plus cosine squared x equals
Cosecant squared x. Awesome. Okay. All right, good. We will use Nick's identity probably the most, but you will definitely see and hear and use Mikey's and Larry's also. All right. The other thing I want you to kind of pick up on is you're going to start to notice kind of some patterns or some mathematics that we kind of do kind of regularly to simplify these. So I want you to kind of pick up on those patterns as well. All right. This cosecant of x, I'm not highlighting, am I? That cosecant of x, how can we rewrite that, Tommy?
You do don't you want to put cosine on the bottom? Cosine on the bottom?
We can't move where the cosine is, or that would change the value of it. But the cosecant, we can rewrite that. Somehow we want to rewrite that so that it has sines and cosines. What's the reciprocal of cosecant?
Sine.
Sine. So we can rewrite cosecant of x as 1 over the sine of x. Yes?
Mm-hmm.
Okay. If you need to, if it's going to help, then put that cosine x over 1 just to help you remember that cosine's in the numerator and that sine ends up in the denominator. So if we have cosine of x over sine of x, that's one of our identities. What is that equal to, guys? Cotangent x. So we've just simplified that. Notice our final answer doesn't have sines or cosines in it, but we've simplified. We don't have any fractions. Okay. All right, questions on any of those so far? What do you think? It's doable, right? Okay. These next ones get a little bit more complex, and on this one you kind of are going to see like a pattern that develops in some of the work. I'm seeing a sine and cosine. I'm not going to change that, but I do want to change this cotangent. So let's stick with my sine x. I want to keep this as cosine x, but how am I going to rewrite that cotangent x? Sines and cosines. There you go, cosine over sine. Beautiful. Okay, so now we have this. Sine of x over 1 plus, if you think about that, we can combine that together, and that gives us cosine squared x over sine x. So we have sines and cosines, so we've done as much as we can there. But now the issue is we've got fractions, and we're trying to add them. So what do we need? Yeah, we need common denominator if we're going to add fractions, right? So what would the common denominator be? Sine x. So we've got, in other words, we've got to multiply this first expression by sine x over sine x so that we have our common denominator. So let's think about what we have when we do that. And like I said, this is kind of a type of problem you're gonna see pretty regularly, because if you notice on top, we end up with sine squared x plus cosine squared x, that's our numerator, over our common denominator. What can we do from there?
Get rid of the,
Yeah, sine squared x plus cosine squared x is just 1, so we've got 1 over sine x. Guys, what is 1 over sine x equal to? Cosecant x. You got it. Good. Excellent. Okay. What do you think? Questions on that? Does that make sense? Think about kind of that process. Maybe star this one. This is one you're probably gonna come back and wanna look at again. You are gonna see quite a few problems where you've gotta get that common denominator and you're gonna get that sine squared plus cosine squared, either in the top or the bottom. Ari?
How did you get 1 over sine x again?
Because it's Nick's identity. Here, right? We have sine squared x plus cosine squared x in the numerator.
Oh, okay.
You wrote it kind of separate
Yeah.
still, but that's one numerator, right? We can write it as just over sine x by itself, like, right? Do you see that? Okay. We're gonna actually look at number 6, then we'll look at number 5. Let's look at number 6 first. All right. Sine x times cosecant of x, what's that equal to? Yeah. Do you see that? Those are reciprocal, so when we multiply them, we're gonna just get 1. Okay, and we already have sines and cosines for that first term. What is sine of x over cosine of x equal to, guys? It's a quotient identity. Sine x over cosine x is tangent. So sine squared x plus cosine squared x is tangent squared x. And that's, whose identity is that? Mikey, what's your identity say?
1 plus tangent squared x equals secant squared.
Secant squared x. There we go. Not so bad, huh? Okay. So on number 4, we had to multiply to get a common denominator. Another type of problem that you are going to see is that you are going to notice that in some instances we have multiple terms on top and we have a common denominator. And so we want to rewrite each of those terms so that they are separate from each other, basically. So notice that we can rewrite that first term as cosecant of x over sine x, and then minus sine x over sine x. And so, yeah, that minus sine x over sine x, that just gives us 1, right? Okay, so we've got to clean up this cosecant of x over sine x. So how are we going to do that?
1 over sine x divided by sine.
There you go. Yes. Awesome. So we get 1 over sine x for the top, and then that's over, if you're thinking about this as keep it, change it, flip it, which we should be, then you might want to think of that as sine x over 1, just because we're about to have to do keep it, change it, flip it. So do you see that? We end up with 1 over sine squared x minus 1, if we flip this. And what would 1 over sine squared x be equal to? What's 1 over sine x? Cosecant. So 1 over sine squared x is cosecant squared x minus 1. I'm pretty sure you have that as an alternative form for an identity. So look at your alternative forms that I asked you to write down on your reference sheet. Cotangent squared x. You guys are getting this. This is awesome. Yes. All right, questions? Couple more. They're gonna get a little bit more challenging here, but you guys can handle it. I have faith in you. First thing I'm noticing is that I'm seeing cotangents and stuff. So one way of dealing with this problem is to stick with the cotangents, since we have all cotangents, and find common denominator. We could do that, but I want to switch to sines and cosines. So let's think about that. How are we going to do that? So cotangent theta, how do we rewrite that using sines and cosines? Okay, yep, so cosine theta over sine theta. Guys, what is 1 over cotangent equal to? Tangent, right? That's equivalent to tangent, so we're going to kind of skip that step, but let's go ahead right away and just write this as sine theta over cosine theta, right? Are we okay with that? I kind of skipped a step there. Okay, now I'm hoping you guys see that this is similar to what we had up here. Not exactly, but we've got fractions that we're trying to add. We've got our sines and cosines already. We've got to add these fractions, okay? Hey there. Okay. If we're going to add these fractions, we need common denominator. So what do we need to multiply by over here? This denominator is sine, so we need this over here. So we've got to multiply by cosine theta over cosine theta. And then here we already have the cosine, we need the sine. So we're going to multiply by sine theta over sine theta. You see that, guys? Our common denominator then is okay. But we've got some multiplying to do on top. What do we get here? We get cosine squared theta plus sine squared theta. That's someone's identity. So 1 over cosine theta sine theta. And we don't want fractions, remember, so we need to think of this as, how can we rewrite 1 over cosine? Yep, that is secant theta, good. And what about 1 over sine? That's cosecant theta. So there we go, secant theta times cosecant theta. All right. These are getting a little more involved, I think you notice, right? This last one's the most involved, in my opinion, but it's not too bad either, so. All right, let's take a look. Almost done with this, and then we've got a Nearpod we're gonna try, and I will explain about the packet that you picked up, okay? All right, we have, yeah. Sorry, Mikey.
For the last one,
Yep.
the answer is both of them, or is there?
Yes, that's the final answer. Are you okay with that? Okay. Yeah, it's those two trig functions multiplied together.
So it's okay to have 2 different as long as.
Yes, as long as there's no fractions. Yep. Okay. I'm glad you picked up on that, guys, right? I'm glad you kind of stressed that. Multiple trig functions there, but that's okay, we don't have any fractions. All right, we do have fractions here. We're trying to subtract, so we need common denominator. So in this case, our common denominator is gonna need to be this sine theta plus 1 over here. And then over here, it's gonna have to be this sine theta minus 1. Okay, so we have sine theta plus 1. I'm gonna put minus here. We're gonna have to do some distributing here. Okay, but with this, we are having to multiply sine theta plus 1 times sine theta minus 1. I need you guys to think about that. We're gonna have to FOIL, only really we just have to multiply first and last because the outside and inside are gonna add to 0 because it's the same thing, just one's plus and one's minus. So we get sine squared theta minus 1. So guys, that's our common denominator. All right. We okay with that? All right, so I want to write this with this common denominator. We're going to have to clean that up here in a minute, and we will. But let's focus on the numerator right now. I need you to notice we are subtracting, and it's a quantity. Okay? So we're going to have this sine theta plus 1, and then this is going to be minus sine theta, and then minus a negative, so that becomes plus 1. Do you see that? Make a note about that distributing if you need to. All right, so signs add to 0, and on the top we are just left with 2. And the denominator, I need you to look at your alternative forms for your for Nick's identities. So alternative forms for Nick's identity. You see a 1 minus sine squared theta, but you don't see a sine squared theta minus 1. What's the difference in those two? The only difference is we're basically switching the order and factoring out a negative 1. Okay? So this becomes a negative cosine squared theta. What, JR? What's your question, sweetie?
Because you're subtracting the same thing up top, so wouldn't that be 0 divided by a number which multiplies?
Be careful though, because we've got it, we're distributing this negative. It's minus this negative 1, so it becomes a plus 1. So you have 1 plus 1. The signs add to 0. The signs disappear, but we still have this 1 plus 1. So it's just 2 in the numerator. Okay, does that help? Okay, all right, back to that denominator. Are we okay with seeing that sine squared theta minus 1, and that's a negative cosine squared? It's taking that alternative form of your identity that you know, and what it's opposite sign there because of switching where the 1 and the sine squared is, right? Brock, it's the homework is pages 1, 2, and 3 in that green packet, in that supplementary packet, okay? I don't need it. I don't know if they told you do you have to go back, sign back out with them?
Yeah.
Okay, so don't forget to do that, okay? All right, guys, if it's helpful, put this times 1 so you can think about the fact that we've got 1 over this cosine squared. So we know 1 over cosine is secant, so 1 over cosine squared is secant squared. So ultimately on this problem we end up with negative 2 secant squared theta. Take a look at that. Questions on that?
Sorry, can you explain that last one?
Yep. Okay. Oh, we've got our negative 2. Are you okay with that part, Jacob? That's coming from this. You okay with that? Okay. For the other part, let me try to color code here. We've got 1 over cosine squared theta, right? So 1 over cosine theta is secant. So 1 over cosine squared theta is going to be secant squared theta. Okay? You good? Does that help? Okay. All right. Awesome. Um,